All right, if you're taking an integral calculus course, this is a very tough exam question for integration. Let's go through it. That's why I really wanted to show it to you. I want you to be prepared for your exams. So let's go through the walkthrough. We get a hint here. So we say, evaluate this integral. You may use the fact that blah, blah, blah equals blah, blah, blah. All right, that's good. That's the denominator. Okay, that's going to be helpful. Very helpful. That's hinting at a partial fraction decomposition for sure, that the bottom factor's like that. Well, the first thing we have to do is we can't leave it like this because the power of the top is the same degree as the bottom. So we have to start with polynomial long division. So this question is already incorporating a lot of different skills, not just straight partial fractions. That's the mark of a good exam question, actually. So if you're enjoying content like this and you want to see more exam questions, please leave a like, please leave a subscribe. It does really help. So once we do this long division here, it leaves us with this equation here, 1 plus, and now we see that the degree of the numerator is less than the degree of the denominator, and that's what we need to continue forward. Now, to set up this decomposition, we have to look at the bottom and say, okay, this whole fraction is equal to something over x plus 1 and something else over x squared plus 4. You might be wondering, why is it bx plus c here instead of just a b, which is what we're used to seeing? And the answer is because the degree of the bottom is squared and non-factorable here, we have to leave it as bx plus c. If this was cubed and non-factorable, it would be bx squared plus cx plus d. It'd be even bigger and uglier. But luckily here, it's only this, and it's not too bad to work with. Once we have this idea and we've properly done this, the next part's not so bad. So we multiply both sides by this denominator, and we want to get this equation here. Once we got this equation here, we can already start to solve some stuff. We can say, well, what happens when x is equal to -1? And start to solve for things. It's just algebra from here. And remember, this has to be true for all x values, including x equals -1, including x equals 0, and so on and so forth. So x equals 0 might give us something interesting as well. Interesting in the sense that it just simplifies some things down for us. So the task now is just solving for coefficients. So they're a little bit tricky. It's a great exam question. And once we get these values, then what we can do is we can put them back in to our equation, and we get this here. And from this part forward, we integrate each of the terms. So one of the ones I want to highlight is possibly this one here. The term 2 gives us ln of x plus 1. Term 3, we use another u substitution, and we get ln of x squared plus 4. And that one, when we integrate that, is arctangent. So that's really important, is knowing the arctangent one. So the derivative of arctangent, what that is, and then how to integrate and get back into arctan. That's one sneaky one that I think is going to show up on exams a lot that students should be ready for. Here's your final answer here. You can come to the site and check it out. If you don't know, I'm Sheldon. I show you how to solve mock and modified past exams. I hope this helped.